Hello everyone, I'm Thomas. I'm a software engineer at Bloomberg. I work in the security infrastructure team with Henry and Andre and Tim. So everyone came here to cheer me on. In my free time, in my work, I'm mostly a Git user. In my free time, I like to contribute to Git occasionally. So I work on random stuff, basically. But this talk is about one of my favorite features in Git, which is, as Ed said, I was afraid he was going to take away half my talk. As Ed said, it's a relatively new feature since about 2015. Git exists since 2005, so many people don't know a lot about it. So to start off, who does know about Git Worktrees? Who uses Git Worktrees? Hopefully we'll have a few more users after this talk. Alright, cool. So in this talk I'm gonna start off talking a bit about what a Git Worktree even is for those of you who don't know them yet. Those of you who do, get another beer or some more pizza if you want. Then I'm gonna show you how they can be useful, in which ways I find them useful. If somebody else has any other applications of them, awesome, I would love to hear that. And in the end, I'm gonna finish with some caveats. There are some little problems with it that are not quite solved yet, but I don't find them a deal breaker for my workflow, so hopefully you won't either. Alright, so what even is a Git worktree? So basically, you can think of it as a separate checkout of one of your commits in a separate directory. So it's essentially like if you would clone your repository to a different location and then you can work with it. So this checkout is linked to the main repository, so there is some connection with it. I'm going to talk more about that later. And it shares the object database, the config, and the ref. So all your branches and your commits and everything is going to be shared between the repository. So as I said, it's like a Git clone, so why not just use that? So, for one, it's cheaper to just create a new worktree that has that shares the .git directory with the main working tree. So you don't have to create new pack files or you don't have to recreate everything that you already have. Even though Git internally, I think if you do a local clone, it uses hard links, but still. You still have to create them, and once you work in both repositories, those pack files might get out of sync, so you eventually end up using more space that you might not have. So the shared objects, as I mentioned, it shares all the objects between the working trees. So those allow some interesting use cases for which you'd have to invoke a git fetch every time otherwise. And finally, it allows you to easily keep track of the work trees you have. So if you git cloned to some random location on your file system, then if you're like me, you're probably gonna forget where you put that. Meanwhile, git worktree, the command gives you an easy way of showing all of the work trees you currently have, so you can easily get back to them and work with them and remove them once you're done. So, how can work trees be useful? So instead of just talking with my slides, I prepared a little demo here. So I have 4 use cases. 4 use cases here. I'm gonna go through them in order. So let's start off with the first one, running tests. So for this one, I will actually need 2 windows to show you. And because it's a Git meetup, I obviously am using the Git repository for demonstration purposes. So, take for example, let's say we want to, in the background, test all our commits, because we want them to be clean before we submit them upstream. We want to keep working in our main working tree. We don't want to be blocked by tests. Maybe they take a while, like the Git tests, they take a couple of minutes to run on my laptop. So I don't want to worry about having them run in my main work tree, and then I modify some file, and then the tests do something unexpected because they pick up the new change. For example, in the Git test suite, just to tell you, it's all written in Bash. It runs a couple of Bash scripts one after another. So if you modify one of those while the tests are running, you don't know if the new changes were picked up or if the old changes are still there. So to start that off, I'm gonna add a new work tree. I'll call that one CI. So this command here, git work tree add, and then you give it a path. So this will create a new work tree that's linked to the repository but detached from your master branch here. So normally this creates a new branch called CI. This is some nice feature in Git that helps you if you don't want to type more. However, we don't really need a branch, so we can use the detach flag. So now we won't create a new branch, but it will still check out our head commit into this new work tree. So let's do that. And let's go there. Cool. So just to show you Git status here in our main work tree, we have this untracked file ci.sh, to which I'm going to get later. Meanwhile, in this new working tree, we don't have this. So this working tree is completely clean. It's based on your head commit, so git show head will show you the same commit in both working trees. Cool. So what about tests? So I've written this. Yeah, I usually name them after the branch I'm in, so I got confused. Anyway, so what about running tests? So I have this .ci, this CI script. Sorry, CI. Basically, I'll show you later what exactly it does, but just to show you, it takes two arguments. It takes the working tree in which you want to run your tests, and it takes a commit from which you want to start your tests. So this script always tests a range of commits. So this starts at head $, which is the previous commit, and goes to the current head of this working tree I'm currently in. So let's start this. I told you the Git tests are a bit slow, but I cheated a little bit. So internally, this is using a utility called Git test, which was written by Michael Haggerty. He's one of the core Git contributors. So this caches the old results of your tests. So now now let's go edit something. Because this is a talk about work trees, I'm obviously gonna edit the work tree command. And because we already added a work tree, we don't need this command anymore, right? It's not useful, and I also need to remove this static to make it compile. So now I'll add this, and C, and I'll git add. So now I'll create a new commit, and if you look at the window on the left, this will automatically kick off the tests. And remember, those tests are running in the background in that other working tree. So I commit here, and magically it compiles and starts running. As soon as it's done, it's starting to run the tests. Yeah, you can't see much here because the font is too big, but either way, so now I can keep working on the other side. So for example, I want to remove one of the tests because we said we don't need add anymore, so let's remove that test as well while we're there. And then the test on the left will still pick up that test. So I'll show you in the output afterwards that test definitely has been run, while it wouldn't be run here, obviously, because it's not there anymore. So while these tests run, let's briefly talk about that ci.sh script. So basically, it doesn't do a lot, but it's quite useful. So basically, it's a bash script. If you were here last time, Charles introduced you to bash scripting. And this basically just goes through a loop forever. Does some setup. You don't need to worry about this. This is maybe an important one. It gets your current directory and your current head, and then it just goes into the work tree and runs this git test command there between the base commit we gave it before and the current head. And in the end, we just wait. We do an inotify wait, which is pretty quick. We wait until either the head or something in the refs directory changed. You don't really need to know the internals here, but every time I make a commit, something in those directories will change, or in this file, which then kicks off the tests in the background. So yeah, I find this one very useful. I can keep this running in the background while I'm working on stuff, and it will make sure that each commit I make is clean and compiles. So git bisect will work, and then I can submit my pull request upstream, and I know that it works. So now the final test is almost there. So now it complains failure. This is bad, so don't do that. There's a bunch of failed tests, amongst of which should be this one that we just deleted, which wasn't there anymore in the main working tree. So of course now nobody would accept a change upstream of removing the add command, because while we have our nice work tree, they still want it, probably. So let's just undo it. And so let's undo the commit, and we see it's again testing in the background, all tests successful, and everything's nice again. So this is this is one way you can use it. Make sure that all your commits are clean. Nobody's gonna complain once you submit the pull request or submit your commits to an open source project, because they will like you more if all your tests pass. Cool. So now, going from that, we go to our second use case. We don't need this window anymore. We're not running tests anymore because it takes a while. So now you have a different scenario. Let's go into the Git directory. So say you're in the middle of your work. You have a huge patch series of 123 commits, and you're in the middle of a rebase, and your status is a mess. You have conflict. You may have resolved some conflicts, and all of a sudden, your boss comes in screams at you, everything's on fire, we need to fix something right now. And you're like, oh, I have this nice work here. I don't want to lose that. I did 45 steps already. I only have, I don't know, 70 to go. It's easy now. It's easy from now on. So you're like, I don't want to do this. But if you know about Git Worktrees, you can just use this magic command again and get a clean working tree. Let's say versions fix. So you could add a new work tree. So now in this case, again, Git Worktree add bases the commit that it checks out on your current head. But you want to base this on the master branch because this is in some weird state, so submitting this upstream is not cool. So you could either just use this command and git reset -- hard, or you could add an additional argument, which gives you the commit git worktree add will check out. So now the git command line is, of course, as usual, a bit inconsistent in itself. If you do this, it won't create a new branch for you anymore automatically, which is, yeah, unfortunate. But there is another, you could add another flag. So at this point, you may think it's easier to just not use all these flags and go to your work tree and just check out master there. That's totally reasonable. But now we have this. Now I added this emergency fix. Now I added this new work tree, and it's clean. Its status is clean. The head commit is the same one, if you can remember, as I showed you earlier for the other Git repository, because I used the same repository. So it definitely checked out the master branch. So now you can go make your fix there, and then once you're done, then you can go back to your super fun rebase where you only have 70 steps left, and enjoy the rest of your day. If you manage to fix the other thing before the evening, otherwise you might have to stay there. So this is just to show you the head commit of the rebase, showing you that it's totally different from what we had before. So this is this is very helpful if your boss comes in. And now to one that's more helping yourself. So again, this is the third use case I have. So again, I'm on a feature branch, but now what I want to do is to check out another branch, to look around, see what changes happened there, what my colleagues did. But the problem is that I modified a low-level header. So I modified this cache.h file, which is included everywhere in the Git source code. So I have a compile, so it's very quick now. But if I check out master, M is just my alias for make. So if I check out master, I don't even do anything. I just browse around here and look at a couple of files, see what's going on, find the things that I wanted, and then I go back to feature, and then I go back to my feature. So now I would expect that make is still fast, but it isn't, because make works based on the modified time, and this cache.h file has been modified back and forth, so make doesn't know anymore that it already has a compile here. So now if I do make, it will compile everything again. Now in this case it's fast because I did this before and I have Ccache set up, so so all my compiles are saved in the background, cached in the background. But you've seen that it's doing a lot of stuff that it didn't do before and it didn't need to do before. So again, I'm not going to do it now, but you could just add a new work tree based on your master branch, browse around there, maybe even check out other branches, and your state is still left intact. So this brings me to my fourth use case. This is how I usually use Worktrees. So this kind of pulls everything else that you've seen so far together a little bit. So I have this directory. It's called multiple branches here. It's usually called the name of the repository that I have. So it would be called Git. And in this directory, I have a bunch of subdirectories. So master one is my main working tree. So that's master is checked out there. This is my main working tree. I shouldn't delete that because then bad things are happening because then I removed the .git directory and the other work trees don't know anymore what's happening. But since it's master, I usually want it to be there in any case. And then I have these other branches, which are these other directories which contain work trees, which are named after the branches that are in. So I never even have to decide whether I should create a new work tree, whether it's worth creating a new work tree. I just do it every time, and I can easily switch around. I work on this one now. Head. Show head. This is this head commit. And then if I send this out for review, review takes a while because there was a lot of changes, so people want to take a good look. And then I can just go to this other directory and work on my other feature at the same time without destroying any of my work there, without destroying the make cache, and I can add other work trees for running my CI and everything. So I also told you, so now that I have a lot of work trees, there's a nice command to keep track of them, which is as simple as git work tree list. So this shows me the 4 directories that I have. It would also show me if I'm not as organized and don't have them all in one directory, it would show me the full path to them. It shows me which commit is checked out, which is different in each of them, and the branch that I'm currently on in the end. So yeah, these are basically my four big use cases that I found so far for work trees. I find them very useful. I'm using this latest version of the number 4 that I showed you all the time, both for work and for my work on Git. So I have 10 to 20 work trees for every repository, basically. So now there are some caveats. Git worktree, even as I said, it's a relatively new feature for Git. It exists since 3 years, but compared to the project's lifetime, that's not that long. So they are still considered experimental in the man page. I have personally never encountered like a severe bug that would cause me to lose all my work or something. So fingers crossed, obviously. Hope that doesn't happen tomorrow. But I am confident enough to recommend you to use them as well. So for whatever that's worth. So one thing where you shouldn't use them is probably if you have submodules. Submodule support for Worktrees is incomplete, so it says in the man page, don't use them if you have a super project with a bunch of submodules. I have actually never tried that because I generally try to not use submodules and solve the problem that way. But if you do happen to have some submodules, be aware of that and be very careful with what you're doing, and make sure you back up your work before trying that out. So not only deleting directories with your whole .git directory, also moving directories with Worktrees in them is not really supported. So basically, if you have to do that, you have to end up going to edit some .git files, and you don't want to do that. So if you want to use Worktree, just leave them in one place. They use absolute paths all over the place. So yeah. So having them on your floppy drive or not floppy drive. I'm old. Having them on your USB drive is probably not a good idea, because your paths will inevitably change between machines, and then you're just messing around with Git internals, which is, some people consider it fun, but others probably don't. So I can't recommend it. And then one last thing that's mostly a problem for me is cleaning up the Worktrees. I always forget that I have a lot of them, so eventually they end up filling up my disk, and I need to remove them. So currently the way to remove a Worktree is to just rm-rf it. So unfortunately, that's kind of unfortunate, because you don't have no guarantees that all your work has actually been committed, and you have to be kind of careful. So there is a little bit of help on the way. There's a feature currently under review which is called Git Worktree Remove, which gives you all these safety checks. So it won't let you remove the Worktree if you have untracked files there, if you have uncommitted changes, basically. So you'll, at least if you remove the Worktree, you know that unless you obviously pass some random ---- force flag to make it work. Other than that, you'll have a guarantee that you won't lose your work, basically. So I have some references here. So the CI script is, I failed to mention that before, but it's heavily based on Jeff King's CI script. So he's one of the main Git contributors as well. He uses this in his day-to-day work, so that should be a good endorsement for it. Then the git test command, you can find that there if you want to find out more about how these cached tests work. And finally, the Git mailing list, if you want to report a bug to Git Worktrees. It's a bit inconvenient way to report bugs, because it only supports plain text email, so you'll have to set up your mail clients properly. But so it's a bit annoying. But if you find bugs, please report them anyway. Yeah, I know Ed is shaking his head now. Understandably, ask a friend. Yes. Come to the next Git meetup. Tell me your bug. I'll. Sorry. Yeah, exactly. As she said, or send me a tweet, or yeah, any of those ways will probably be nice, and then you'll get your bug fixed, hopefully. That's all I had. Thanks everyone for listening. I hope some of you will try out Git Worktrees tomorrow at work, or this week, or this month, maybe. Thanks everyone. So if there's any questions. Yes. 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 Right. Yes. Yes. I'm going to repeat that for the camera so people online will not. So Patrick just mentioned, don't use a version lower than 2.15 of Git with Worktrees, because that will actually probably eat your data at some point. So yeah, don't do that. Charles? What do you mean? Like, yes. 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 Yeah, you can change it. It basically acts like a normal Git repository, except it shares the config, it shares the refs, but you can. The head is different, so your head file that keeps track of your commit is different, and the index is different. So for obviously. Yeah. Yes. Yeah. Git will not let you do that. I mean, you can edit your head file and then weird things will happen, but Git itself will not let you do that. If it does, it's a bug and should be fixed. Sure. Yeah? Hmm? Yes. So no, this is so you can't have master in both directories. So this is Git protects you against that. But if you have master and do a Git pull, if I understand correctly, then you merge the head in that particular directory, and yes, it acts like a Git fetch for the other working tree, because you updated basically your object database, which is shared between the two working trees. So yes, that would act like a Git fetch for the other one. That makes sense. Oh yes. Yes. So yeah. So that test script goes into the other working directory, and the git test script then gets this commit that I just made from the master and pulls it into the CI working tree. The script is doing the watching via that, so via that I notify wait if what was it called, ci.sh. So that I notify wait is doing the watching. And so you can see here, so every time it goes cd worktree first, so it goes into that CI directory that we created first. And then it runs the tests, and git tests automatically gets the new commit from this working tree. So everything that I have here in the git test one, this all happens CI. So basically, this is as if I would do git test run head here. And this is the output that the script shows. You mean? Yes. Yes. Here. Yes, because here we get the head from the other directory, so from the master. So we want to test that's the newest version, the newest commit that I just made. So this is where it's coming from, and then it checks it against the. Sorry? Yes. Yes. Got many heads. And you will only ever have more and more. All right. Thanks, everyone.